NASA pulls go for launching humans to the moon while disagreeing with SpaceX over the Starship lunar lander. We also got some updates about upcoming rockets, and NASA starts building its next space rotorcraft. As always, we've got all that and more coming up this week in Spaceflight. NASA is ready to launch humans to the moon. The agency performed a 2-day flight readiness review for its Artemis II mission, and the outcome was a unanimous go. Of course, the rocket isn't at the pad right now, so they still have a few things to do before they can actually launch, but they don't foresee any deal breakers at this particular moment. We've been following the preparations for Artemis II and the problems that arose along the way on previous episodes, but here's a very quick recap just in case you missed it. The agency rolled out the SLS rocket earlier this year with the intention to test it and then start the launch campaign. That wet dress rehearsal test was, however, plagued by hydrogen leaks, which is of course no surprise to anyone who followed the space shuttle program or the Artemis I mission for that matter, but it was something that needed fixing. The agency got to work and performed another wet dress rehearsal on February 19th. That one went flawlessly, but just a few days later, NASA announced that it would roll SLS back to the vehicle assembly building to address issues with the flow of helium into the rocket's upper stage. But that's all in the past now. Studying the problem, technicians found a seal blocking the flow of helium in a quick disconnect. Teams quickly tried to replicate the problem in a test facility and even made some design tweaks to fix the issue. That's some rapid iteration on SLS. Now, if you watched our recent video comparing SLS's design process with Starship's, you'll know that that isn't how they usually do it. Either way, with the helium issue now resolved, NASA went into its flight readiness review and pulled go for a launch no earlier than April 1st. No joke, that really is the launch date. Now, of course, they still need to roll SLS back out to the launch pad, and there are a few things that need to finish up before they can do that, but they expect to have the rocket ready to roll by March 19th. And if it all goes well, the 4 crew members will have entered their pre-launch quarantine the day before. Then they'll travel to the Kennedy Space Center on March 27th, 5 days ahead of the scheduled launch date. Given all the issues, you might expect that NASA would want to do a few more tanking tests to verify that everything is now sealed up correctly, but they're not planning to. They tested out the new helium quick disconnect while in the VAB, and they're confident in the other seals and believe that there's nothing more to be gained by doing another test. They also don't want to wear out the tanks with any unnecessary tests. So, the next time they'll fill up the rocket will be for a launch attempt. We'll see how that all works out, but worst case, they'll have to eat into the launch window. There are launch opportunities on each of the first 6 days of April, and another one on April 30th. Hopefully, those will be enough to finally launch humans toward the moon again for the first time in over half a century. Artemis II is just the beginning. Under the newly revised Artemis program, humans will land on our celestial companion during the Artemis IV mission in 2028. During that mission, the astronauts will board one of the 2 vehicles developed under NASA's Human Landing System program, SpaceX's Starship and Blue Origin's Blue Moon Mark II. The program hasn't been without its issues, though, and just last year, the agency tried to push SpaceX and Blue to accelerate the timeline. This week, NASA's Office of Inspector General released a report evaluating how the agency managed the program, and it raised a few interesting points. First of all, the report concludes that the concerns over Starship being ready in time weren't unfounded. The failures of Starship Flight 7 through 9 severely delayed the program, and in fall 2025, SpaceX told NASA that there was a chance that they couldn't meet NASA's June 2027 target for the lunar landing. This prompted NASA to ask SpaceX and Blue for plans to support a date in 2028. It wasn't all SpaceX, though, as Blue had also delayed the Mark II lander by at least 8 months. Beyond the delays, the report raises some other concerns, and some involve disagreements between NASA and SpaceX. NASA requires the lander to allow crew to take manual control if needed. And this was needed during every single Apollo landing, and also made a big difference when Starliner suffered from thruster issues. The problem is that NASA doesn't like SpaceX's manual control implementation for Starship, while SpaceX believes that it satisfies all the requirements. The Office of Inspector General seems concerned that if the 2 parties don't figure out a solution, Starship might only end up supporting automated landings. Historically, that seems to be a very risky approach, even though technology has come a long way. Other concerns stem from the height of both vehicles. The landers aren't vertically challenged at all. They are much taller than anything that has landed on the moon before. The lunar surface isn't exactly even, though, so landing on a slope poses a real risk of falling over. But even if it doesn't, and well, let's hope that it never will, Starship's height is still a problem. The only way for the astronauts to disembark the spacecraft is by using an elevator. The report isn't particularly keen on this, as there's no good backup in the event of the elevator failure. And while SpaceX did design the elevator with redundancy, it's the only way to get into the lander from the surface, and that's risky. So what to do? Well, the report makes a few recommendations, including implementing some lessons learned from the Commercial Crew program, in which SpaceX and NASA also disagreed over manual control. Hopefully, they'll find a way to fix the issues and the disagreements without adding too many more delays. We'd love to see another moon landing, but more than that, we want to see those astronauts return home safely. Remember NASA's DART mission from a few years ago, when the agency launched a spacecraft to collide with an asteroid called Dimorphos? Well, you might already know that it was very successful at changing the asteroid's orbit around its companion Didymos. But this week, we learned that the mission also changed the path that the pair of asteroids take around the Sun. To recap, NASA launched its Double Asteroid Redirection Test, or DART for short, as an experiment to test if we could push an asteroid off its path should that ever become necessary for planetary defense. They started small with the mission and crashed the spacecraft into Dimorphos, hoping to change its orbit around Didymos. If it worked on a small scale like that, it would, at least in theory, be possible to scale up to deflect larger asteroids from colliding with our home planet.
It's about it. We're coming very... there we go. All right, DART hit.
Look at that!
That's the last image, yes.
Yes, we did it!
Do you have pom-poms, Alicia? You're like, cheer.
I do, because this is amazing.
And it worked. On September 26th of 2022, the spacecraft crashed into Dimorphos at roughly 22,000 kilometers per hour, shortening the asteroid's 12-hour orbit by about 33 minutes. Now it turns out that the mission left another mark. It also changed the orbit of the asteroid pair around the Sun. Now, it's only a small change, as the orbit was slowed by about 12 microns per second. That's 12 millionths of a meter. It adds up to about 780 meters for each lap around the Sun, or a change of 0.15 seconds to the pair's 770-day orbit. That's tiny, so what? Well, give it years and it makes a huge difference. But more importantly, this is the first time that we've ever measured humans changing the orbit of a celestial body around the Sun. But how do you even measure a change that small? Well, besides directly observing the asteroid with radar and other ground-based telescopes, astronomers tracked stellar occultations. These happen when the asteroid passes in front of a background star from our perspective, causing the star to disappear from view for a moment. It's not easy, but with the help of volunteer astronomers from around the world, the team recorded 22 of these occultations between October 2022 and March 2025. And when they crunched the numbers, they found the minute orbital change. Very impressive. There's even more from DART though, because another study was published at the same time that focused on the images that DART took before its collision. The scientists found interesting patterns in the images corresponding to stuff hitting Dimorphos at low speeds. But where could that come from? Well, Didymos. Yes, Didymos has been slinging material at its companion. This happens because the sunlight changes Didymos' spin rate through an effect known as the Yorp effect. That change is enough for some rocks on the asteroid's equator to overcome gravity and venture out into space, where they then run into Dimorphos. It just goes to show how much one mission can teach us about these asteroids. But here's the good news. There's more to come. Europe's Hera mission is set to arrive at the asteroid pair in November. This mission will study the asteroids and the impact left by DART in detail, and we'll even see 2 CubeSats attempt landing on Dimorphos. Not only do these missions give us a wealth of insight into our solar system, but they also help us to prepare for the day that we may need to nudge an asteroid off a collision course with Earth. Hot on the heels of this week's DART update, Blue Origin has also revealed that it's working on a planetary defense concept of its own. Neo Hunter is a mission concept to protect Earth from potentially hazardous asteroids using deflection techniques. It's been designed alongside NASA's Jet Propulsion Laboratory and Caltech, and it's based on the company's Blue Ring platform. You may remember we recently reported that the European Space Agency is planning to deflect objects in low Earth orbit using high-powered ground-based lasers, while French company Osmos X intends to nudge debris in LEO using an ion beam from its orbital transfer vehicle. Well, Neo Hunter would use a similar similar principle, using an ion beam to gradually deflect the trajectory of an asteroid. It would first deploy CubeSats to characterize the asteroid, before then approaching it and directing the ion beam to alter the object's path just enough to remove the threat. And if that doesn't prove to be enough, the craft can also take a page out of DART's playbook and slam directly into the asteroid to alter its course. Neo Hunter will have almost 9 times the mass of the DART spacecraft, and for this method, which Blue describes as robust kinetic disruption, it could impact the asteroid with 1.5 times the energy. That combination of a heavier spacecraft and a higher energy impact would deliver a far more decisive blow, shifting from a gentle nudge to something capable of real disruption. This hybrid approach of beam deflection and momentum transfer is just one use for Blue's versatile and highly maneuverable platform, which will also provide the foundation for the company's proposed Mars telecommunications orbiter. A test asset for the platform underwent structural load testing this month at NASA's Marshall Space Flight Center in Huntsville, Alabama, while the first Blue ring for flight is currently undergoing testing in Blue's factory. NASA also has another planetary defense mission in the works, the NEO Surveyor mission, which was announced around this time last year. The telescope will launch no earlier than next September aboard a Falcon 9 and will spend 5 years surveying the heavens from the Sun-Earth Lagrange point 1. NASA hopes that NEO Surveyor will find at least 2/3 of the undiscovered near-Earth objects currently hidden by solar glare or darkness. The Surveyor will use infrared to search for these potentially hazardous objects, which measure at least 140 meters and could cause major regional damage if they were to hit the Earth. The plan is for NEO Surveyor to significantly contribute towards the congressional goal of cataloging 90% of these near-Earth objects. We'll be keeping a close eye on these missions as they develop, all part of the effort to find hazardous asteroids and comets long before they ever find us. Now we'll take a look at some other stories across space, starting with more news from Blue Origin, as the company shared a video of a hot fire test of its 5th New Glenn second stage. The test took place at Blue's Launch Complex 36 at the Cape Canaveral Space Force Station on Florida's Space Coast. This is the historic Atlas launch pad, now leased and rebuilt specifically for New Glenn. 2 BE-3U engines power the upper stage, using liquid hydrogen and oxygen for propellant. The test saw the engines ramp up to around 780 kilonewtons of thrust each, verifying ignition, throttle ramp up, and integrated stage performance. Blue is really building up hardware as it prepares for its 3rd launch of New Glenn. The payload fairing arrived for the mission last month, with AST SpaceMobile's Bluebird satellite encapsulated inside. This mission is set to launch later this month from the same pad and will scale out AST's space-based cellular broadband network even further. Bluebird 7 is the second in the company's next phase, through which it plans to bring direct-to-smartphone connectivity to nearly 6 billion mobile users worldwide. Each new Bluebird satellite deploys a 223 square meter phased array antenna, which are among the largest commercial communications antennas ever flown in orbit. From Blue's engine testing at LC-36, we move to Mississippi, where Relativity Space continues testing its Aeon engines at NASA's Stennis Space Center. Propulsion testing is ramped up here for its Aeon R and Aeon V vacuum engines, which are destined to fly on the company's reusable Terran R rocket. Relativity continues to manufacture and ship more engines as it ramps up production rates. 13 of these Aeon R engines will power the first stage, with 1 vacuum-optimized Aeon V on the second stage. The company recently leased the historic A2 test stand, which is being upgraded for vertical first-stage testing of Terran R. This month, the load ring was lifted into place. This is the reinforced structural interface that supports the stage during tests, absorbing those dynamic forces while still allowing controlled movement. The launch site itself also continues to grow at Launch Complex 16 in Florida. The horizontal integration facility is visibly taking shape now, and piles have been driven roughly 30 meters into the ground for the pad's lightning protection system. The massive upper strong back for the transporter erector has also now arrived at the site, weighing 500 metric tons. There's still more outfitting work to follow, but it's yet another sign of progress towards completing the infrastructure for launch. As the company develops the ability to manufacture at scale, work continues on the second flight vehicle in parallel with the first. This month, Relativity completed a high-fidelity computational fluid dynamics analysis of the vehicle's grid fins, delivering accurate predictions of the unsteady aerodynamic loads that they experience during descent. We can't wait to see those fins in action as the first stage returns for a propulsive landing. We'll keep watching as Terran R strides ever closer to its maiden flight. Rocket Factory Augsburg has shipped both stages for its RFA One rocket to the SaxaVord spaceport in Scotland. This is a major milestone for the company as it steps towards a maiden launch this summer, currently targeting a window around June to August. The second stage was the latest to arrive following a successful hot-fire test at Sweden's Esrange Space Center. It joins the first stage, which was built and tested in Augsburg before arriving at the spaceport in early February. The 9 Helix engines for this first stage remain in Sweden, where they're currently undergoing final acceptance testing. They'll be shipped on a rolling basis for on-site integration at SaxaVord, where the full vehicle will be assembled and tested in the spaceport's newly completed assembly, integration, and testing hangar. Once the stages are integrated and checked, we can look forward to a static fire of the full stack on Launchpad Fredo to validate a variety of systems. RFA was the first company to hold a UK vertical launch license, which it was granted in January of last year. The company occupies SaxaVord's one completed launch pad, while 2 others are in various stages of development. This process is positive news for European spaceflight, especially on the heels of the recent news about Orbex going into administration, whose prime launcher was also expected to launch from SaxaVord. We'll keep you updated on progress as RFA One edges nearer to the launch pad and prepares for the first orbital launch from UK soil, and its first vertical one too. And if you want to follow along with this and other news, you know what to do. Like and subscribe to get notified when we post our spaceflight updates. The Federal Aviation Administration has issued a favorable payload determination for VAST's Haven 1 space station this week. This is a key regulatory milestone for the commercial space station, indicating that the payload, the Haven 1 module, meets requirements for launch licensing and related approvals. The determination followed an interagency review involving NASA, the State Department, the Commerce Department, and national security stakeholders. Haven 1 is on course to become the world's first commercial space station and is currently targeting a launch in the first quarter of 2027. It's a single module station that will accommodate crews of private astronauts and researchers for 2-week trips and will act as a bridge towards larger follow-on stations like Haven 2 following the retirement of the International Space Station. Astronaut advisor Megan MacArthur has been providing feedback on the design for its sleep system. Haven 1 sleep pods employ carefully tuned lighting, gentle airflow circulation, and a comforting pressure layer to ensure that every crew member gets the deep restorative sleep that they need. DOS even got to test out a prototype when NSF visited VAST headquarters last year. Each unit sits inside one of Haven 1's 4 private crew quarters, which are slightly roomier than the ISS versions and include a built-in storage and vanity area and Starlink-enabled connectivity for calls home. Last month, NASA selected VAST for its 6th private astronaut mission to the ISS. This will be VAST's first private mission and will launch no earlier than summer 2027 aboard a Crew Dragon. The commercial crew will then spend up to 14 days at the orbiting laboratory. From Crew Dragon, we move to Dragonfly, NASA's car-sized, nuclear-powered rotorcraft lander designed to explore Saturn's largest moon, Titan. Integration and testing of the spacecraft is officially underway in the clean rooms and control rooms at the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland. Teams will now bring together Dragonfly's major systems, including its rotor assemblies, avionics, power systems, and science instruments, to begin testing how it performs as a single integrated spacecraft. This stage is crucial for verifying that everything works together before it enters full environmental testing. Integration testing will continue into 2027 ahead of a launch aboard a Falcon Heavy no earlier than July of 2028. So what does the Dragonfly mission aim to achieve? Well, Titan is one of the most Earth-like worlds in the solar system, with rivers, lakes, and rain, though they're all made of liquid methane. When it arrives around 2034, Dragonfly will descend through Titan's thick atmosphere and begin hopping between locations using its 8 rotors. By sampling different sites, it'll investigate Titan's chemistry, geology, and atmosphere, searching for complex organic molecules and clues about the chemical processes that may resemble the early conditions that led to life on Earth. Dragonfly is the first mission of its kind, and if successful, will become the first rotorcraft to conduct powered exploration on another moon, opening a completely new way to explore planetary worlds. Das and I went deep into the Dragonfly mission and rotorcraft on a recent Astro livestream with the Dragonfly team, so be sure to check that out to learn even more. Now let's check in with Stoke Space and its fully reusable Nova rocket. This week, the company announced that it had sent off the second stage Andromeda development engine after completing numerous tests. After firing for a total of 5,400 seconds, team members gave the engine an appropriate sign-off. Propelled by burning liquid hydrogen and liquid oxygen, Andromeda will power Nova's second stage on the way up and also on the way down for propulsive landing. It's a pretty unusual engine for several reasons. First, it consists of 24 thrusters, but is still considered a single engine because all these thrusters share turbo machinery and other components. What makes this engine even stranger is that it doubles up as the rocket's heat shield, which is cooled by running propellant through it to protect the stage from the heat of re-entry. This unconventional setup also means that Nova's 2 stages connect through the engine. Just a few weeks ago, Stoke showed this off by sharing pictures of a fit check during which the engine was connected to a Stage 1 forward module. Now just imagine the rest of the stages above and below, and you can start to see how wild this rocket will look when it actually launches. Hopefully, we'll get to see that later this year, as while we haven't actually seen a completed rocket yet, the company says that it's planning to launch in 2026. They recently completed the launch pad at Cape Canaveral, so all we can do now is wait for a rocket to show up. Continuing on the topic of engine tests, PLD completed the second phase of its liquid propulsion stage recovery project for the European Space Agency. For this project, the Spanish company tested its Temporal C engine, which will power the upcoming Miura 5 rocket, which is set to fly for the first time later this year. The rocket's upgraded Block 1.2 version is supposed to be partially reusable, as it has the ability to propulsively land its first stage. The liquid propulsion stage recovery project isn't just about propulsion, though. In fact, the project's first phase tested landing a booster under parachute after dropping it from a helicopter in 2019. For the now completed second phase, PLD studied a whole bunch of systems and how they can cooperate to optimize reusability. This involved propulsive braking during re-entry and modifying the trajectory with the goal of landing as close to the launch site as possible, allowing for quicker recovery. PLD plans to incorporate these results into Miura 5's recovery program. The rocket's first flight, set for later this year, will use the rocket's first version, which doesn't support propulsive landing, but down the line, the Block 1.2 version will introduce this capability and allow the smallsat launcher to increase its cadence to 30 flights per year. But honestly, for the time being, we'd just be happy to see them get that first Miura 5 off the ground this year. This is your weekly space traffic report provided by Next Spaceflight. As usual, SpaceX launched a few Falcon 9s this week, including the rocket's 30th flight of the year, which lifted off from Cape Canaveral to launch the EchoStar 25 into a geostationary transfer orbit. Once operational in its geostationary slot, the broadcast satellite will provide TV coverage across North America. This was the first non-Starlink Falcon 9 launch in a while, the last of which was the Crew 12 mission a month ago. Of course, Falcon 9 also lofted some Starlink satellites this week too, across 2 launches from California. Also launching from the Californian Vandenberg Space Force Base was Firefly's Alpha rocket. Yes, we've been talking about this launch for a while now, as it was delayed several times due to weather and technical issues, but this week it finally lifted off. Alpha's 7th mission, named Stairway to 7, marked the rocket's return to flight after the failure of Flight 6 in April of last year, which suffered an anomaly at stage separation. After solving the problems, but then losing the booster that was originally set for Flight 7 during a test in September, Firefly was finally ready to try again this month. On March 11th, Alpha lit its 4 Reaver engines and took to the skies, and this time it successfully made it all the way to orbit. The mission's primary purpose was to test technology for Alpha's Block 2 variant, which will debut on the next mission, but we later learned that Alpha also carried a demonstrator payload for Lockheed Martin. We're glad Firefly is back to launching rockets and can't wait to see Block 2 on the next one. Later this week, China also returned from its break for the Chinese New Year celebrations, launching a Changzheng 8A from Wenchang. Encapsulated in its fairing was a batch of internet satellites for China's Satnet Leo constellation. Just a few hours later, a Changzheng 2D lifted off from Xichang, launching 2 satellites for testing Earth observation technology. The country plans to continue launching next week, with the Changzheng 6A set to lift off from Taiwan on March 15th, followed the next day by a launch of the state-owned company X-Pace's Kuaizhou 1A rocket, which will lift off from Zhoushan. Rocket Lab also plans to launch another Electron next week from its own spaceport in New Zealand. The mission, named 8 Days a Week, will loft another Strix satellite for the company's repeat customer Synspective. Over in Norway, the launch window is set to open for the second flight of ESA's Spectrum rocket. Now, this mission has been on the books for a while, as issues with a pressurization valve scrubbed the launch earlier this year. Hopefully, everything progresses smoothly this time around, and the Onward and Upward mission finally gets to go, well, upward. And of course, SpaceX is also planning to launch more Starlink missions this week, with 5 currently scheduled, 3 from Florida and 2 from California. As always, more launches could pop up throughout the week, so we recommend checking out nextspaceflight.com and installing the app on your phone for the latest updates. And that's your weekly update of spaceflight news. I'm Alicia Siegel for NSF, and we'll see you all again next week to recap this week in spaceflight.